Okay, ready? Here we go.
The triangle. Here's a sample triangle, and let's color its three angles. Now this angle over here is 51 degrees. This one is 62 degrees, and this one is 67 degrees. So what's the sum of these three angles? In other words, what's 51 degrees plus 62 degrees plus 67 degrees? And if you'd like to review what angles are instead, then click over here.
Okay, you guys take a second, add those three numbers up for me and tell me what you get. 180. Yeah, basically everything today is just going to be 180. But we'll see why.
Right. The angles in this triangle add up to 180 degrees. Now here's an interactive version of the triangle where you can drag around the three corners and make any triangle you want. The three angles are also shown over here, and at the moment, they add up to an angle that forms a straight line. In other words, the measures of the three angles add up to 180 degrees. Try making a triangle whose angles add up to something other than 180 degrees.
So I'm just going to drag these around. No matter how small it gets, do you guys see how it still equals 180 degrees? Or I can make it super big. And again, it doesn't matter where I put these. Still equals 180.
Seems like the angles of every triangle add up to 180 degrees. Let's see if we can prove this is true using this triangle here, whose angles have measures that we'll call A, B, and C. As a first step, pick any of the three corners of this triangle.
Which one should we pick? C.
Okay, you picked this corner over here. Here's the line that goes through the opposite side of the triangle, and let's make a parallel copy of this line that goes through this corner of the triangle that you picked. So these two lines, over here and over here, are parallel. Now let's look at this yellow angle over here. Which angle inside the triangle forms an alternate interior pair with this one? Is it angle A, angle B, or angle C? And click over here if you'd like to review alternate interior angles.
So which one's alternate interior to this yellow one? A, B, or C? Is it which one? Yeah, it sure is.
Exactly. Because these two lines are parallel, this angle here has the same measure as this one over here, because they're alternate interior angles. So this angle has measure B as well. Now, which angle inside the triangle is alternate interior from this one?
A, yes.
Right, this angle has the same measure as this one over here, because they're another pair of alternate interior angles. So this angle also has measure A. Now notice that these three angles add up to a straight angle. So what's A plus B plus C?
180. Yeah, they sure do.
Exactly. The sum of these angles is 180 degrees. And this is true for any triangle. The three angles in every triangle always add up to 180 degrees. Now that you've proven that the angles in every triangle add up to 180 degrees, here's one last chance to try to find a counterexample. Maybe there's some triangle out there whose angles add up to something other than 180 degrees.
Do you think I can make a triangle where they add up to something different? No, I don't know why they're letting us try again. We already said it's not possible.
Okay, next question. Here's a triangle, and let's say this angle is 30 degrees, and this angle over here is 90 degrees. Using the fact that the angles in every triangle add up to 180 degrees, find the measure of this blue angle up here.
What would that missing angle be? Right, so 180 minus 90 minus 30 gives us 60.
Nicely done. The three angles in this triangle must add up to 180 degrees, which means this angle has to be 60 degrees. So for your final challenge, suppose I tell you that the three angles in a triangle have measures of x, 3x, and 5x. Try using this information to solve for the variable x. If you get stuck, click down here.
Okay, so these are our angle measures, but instead of having numbers, they're variables. How many total x's do we have? So like 1 plus 3 would be how many? 4, right? And then 4 plus 5 more gives me? So now we know that 9x has to equal 180. So what's 180 divided by 9? Woo! I think we did it. Okay. Well, now that we've watched that, that's basically what our notes are like. So let's do a few examples in our notes packet so we have that in case we need it for a test or quiz. And then we will get rolling with the rest of our day.
What's the name of the package?
This one had the triangles on the front, like classifying triangles. Yes. Yes, that one looks like it's right. Angles and triangles. Okay, so we said the sum of the angles added to what? 180. Yep. So now our job is to find the missing angle on these first two. So we're looking for the measure of angle B. So you just subtract away the other two. What do we get? 75? I think that sounds right. This one's 75 degrees. Same idea on number 2. $65? Yeah. Okay. Will you guys get rid of the +2 on angle P so you get a nice whole number when you do this? Otherwise, if you leave it how it is in your notes, you're going to get a decimal. So get rid of that +2, so it's just 5x here. But our job is to figure out what the value of x is and then plug back in to find each angle measure. So what do all three of these have to add to? 180. So let's write that out. Yes, we have to figure out how many x's we have. So, yep, 7 plus 7 gives me 14, plus 5 more is 19. Plus 9, yep, I agree. Minus our 9 over. Yep, and we divide out. The tan one, the third sheet in. 9. And now we plug in to find the angle measure. Where do you guys want to start? M, N, or P? M. So if we plug in 9, seven times 9 is 63. Plus 8 gives me 71. Oh boy, hold on one sec. Did you plug in right here? 7 times 9 is 63. Plus 1 is, oh, I see what you said. I misunderstood you. Yep, 64. And then you can always check yourself too if you're wondering if you did it right. You could add 71, 64, 45, and you should get 180, but I think we're okay. Okay, and then we have this thing called an exterior angle. Do you guys see how we have this blue triangle and then we extended this bottom side? Well, that's when it forms an exterior angle. That's this guy right here. So if we can say angle formed by extending one side of a triangle. Okay, so now let's find some angle measures of these guys and then we'll be done for the day. So our end goal is to find the exterior angle, but before we can figure out what this guy is, we have to find the missing angle of that triangle. So it's the same process that we were just doing. What's 180 minus 60 minus 60? Perfect. So now if this angle right there is 60, what do these two have to add to if they make a straight line?
180.
Yeah, 180, right? So I can take 180 and take away that 60. And what do we get? 120. Yeah, so that's our answer. 120. Okay, let's try another one. So we start by subtracting away from 180. $25, yep, that's what I got. So if this angle is 25, to find angle 3, we subtract from 180. $155, right? You guys try that last one, see what you get. Then we can check. So 113, did I do that right? Okay, I'll show you guys a shortcut. So you can do it the long way every time and it will work. Or, what happens if you take these two angles? What's 60 plus 60? What do you get? 120. What's 125 plus 30? 58 plus 55 is? Yeah. So these two angles add to the outside one. So that's a little shortcut for you.
What if there's just an outside angle and then like one inside angle?
Then you could subtract them, right?
Yeah. So you just draw one outside.
So like if you were looking for like this angle right here, you take 113 and subtract 55.
Okay.
Does that make sense?
Yeah.
Okay. Okay, so now let's do this last one using the shortcut. So we just said that this angle plus this one equals that guy. So 60 plus x equals 2x plus 4. Subtract the x over. Minus 4. Six. Did I mess up?
Wait, no, it was 4.
We're okay?
Yeah.
Okay. And if we plug back in, so this angle right here would be 56. Then this one, 2 times 56 plus 4. What does that give me? Yeah. Woohoo! We made it. If you want to go